Hi, this is Grover with Blue Collar Codes, a quick and dirty. I'm going to go over episode 10, more looping concepts, the help built-in function, and dynamic typing. If you wish to follow along, there is a link to the GitHub repository for episode 10.py in the video summary. So I'm going to go ahead and go over nested loops just to show you how they function. And so to do that, I'm going to go over to the interactive prompt here and create two simple lists. And so what I want to show you is just how looping would work in this instance by doing nested for loops. So for I in L, print I, and then for x in L2, I'm going to print x. So note here how I'm just looping through the objects. I'm not looping through index by index position. And so what you want to note here is that it'll go through the outer level, which is a for loop through L, the list 1, 2, 3. And so what it'll actually do is it'll print that first I value in L, which is 1, and then it'll go in and it'll perform the entirety of the inner loop first before it will then go back and loop through the second item in the outer loop. So I just wanted to showcase here for you how loops will act when they're nested, in that the internal one will complete its loop first before going back and implementing the next round in the outer loop. So that's one thing to showcase here. And the other is to showcase how to segregate or filter out the values that you're actually going to process. You can use the break or continue. So outside of simply doing like an if, else if, it would be if a condition is true, then break. So you want to be done with the entirety of the loop. So I'm going to do the same thing, but I'm going to put in break for when it reaches a value divisible by 3. So that'll just mean that we're going to skip the 9 and break on that. Well, actually, maybe I'll go and do the 7 instead, just to showcase for you that the rest of these won't be utilized. It'll just do the 7 and then it'll break on that. So for I in L, print I. Oop, don't need that. For x in L2, if x equals 7, let's say 8. So it'll process the 7, but then it'll break on the 8. So if x equals 8, then we're going to break, else. You don't even need to have an else. You can omit entirely anything else, and it'll continue through the loop. Oh, I didn't put the print in there. Let me do that again. So what I would want to do is if x equals 8, then break, elsewise I'm just going to put a print the x value. And so since it breaks, it'll skip this last line. So just showing that for you. So it goes 1, 7, 2, 7, 3, 7 because it broke at the 8. And break basically means it's exiting just out of the inner loop, or just the loop in which it's contained based on indexing or indenting. So it's only going to be pertaining to this for loop, or the enclosing loop, not to the external loop. So in continue works in much the same way, except what you'll find is it will just skip that iteration and then go back and start the next one. It won't break through that loop entirely. It'll just skip that current round. So we'll go over that right now. Let me first type clear so you can see it. Then for I and L, print I, and then for X and L2, I'm going to do if X equals 8, continue, else I'm going to put a print X. And so what you have here is it just skipped the 8. As you can see, it just continued past. It went to the next iteration. It didn't break through that iteration. So that was briefly going over what you can accomplish using continue and break. And to showcase a bit of the help function, I mean, pass is pretty much generic. It'd be like if you wanted to just enter in a blank template and fill out the conditional statements later, then you could use pass. Or if you simply want nothing to be done, then you can put pass in there as well. But to go again back to the help, it's basically a way for you to, I would imagine, during the interactive prompt, just get additional information on what type of inputs or arguments a method takes, or what type of object is returned when a method runs. So, for instance, we can do help and then do list. And it ends up giving you a lot of the information as far as what methods it has and what arguments it takes. And so here it says list, it takes an iterable, and then you can keep clicking through to get all of the information you could want. And so that's just useful if you say, I mean, it becomes more and more useful if you don't have internet connection or you're on the go and you need to get additional information. It's also quick and easy. You just type the help, where you might have to search on, a search engine and get results you may not be looking for. And here it gives you at least the bare bones information. It doesn't tell you how to use all of this stuff 100%, but at least it gives you, hey, does it have, I can't remember, does it have this? What does it do when you want to set an item? Or what happens if I clear it? Or how do I copy a list? So is it copy or copy to or whatever? So it just gives you that additional information. And then going down to dynamic typing. Dynamic typing is essentially the fact that you're not declaring variables ahead of time. It just makes things a bit more flexible, and it's very Pythonic, quote unquote, to utilize dynamic typing to its fullest by not checking for types, but just checking for utility, checking attributes, and making sure that it can work via attributes on the object level versus trying to check that the variable has a type to it. And so what that means is that you can go ahead and you can create A equals a string, and then you can automatically assign A, B equals string. And what that ends up meaning is that these two are just referenced by this name. They're not hard-coded to be that 100% of the time. So a part of the is and ID is checking if they're the same object, which they should be based on how Python uses for smaller objects. It creates one in memory and then it shares that reference versus creating an identical object in memory. So A is B, and we'll get true, but you can change A to something else, like a float, and now we have A is B, and that's false, because A is now a float. And so that's some of the stuff that I wanted to go through. Dynamic typing gets a bit more involved, but that's the nuts and bolts of it. It's basically that the type doesn't live on the variable name level, it lives with the object itself. And so that changes the way that you can utilize or program things by not being hard typed. Again, this is Grover, Blue Collar Codes, Quick and Dirty, episode 10. Join us next time. We're going to go over some scopes.